Okay, Spartan fans, today we are going to talk about Intro to Series. I recommend a calculator, graphing, or scientific. Speaking of calculators. So just looking ahead, part one of your final exam, which I've already been telling you about before, is going to be on Tuesday, June 3rd. And it will be no calculator of any kind. And it will be a short answer, which is the kind of test that you're used to taking. Right? Here's the problem, answer the question. And then part two, which will be on the regular exam day, so sixth period, I'm not sure exactly what day that is. Maybe it's Thursday. Part two will be all multiple choice, and it will be scientific calculator. If you do not own a scientific calculator, go get one. You're going to need it in trig honors. You're going to need it in calculus. You're probably going to need it in chem or bio or physics and everything else. So get a scientific calculator. Yes, I have some you can borrow, but once they're all lent out, that's it. Okay, so first thing we're going to talk about today is a series. So a series is the sum of a sequence. And it could be an arithmetic sequence, it could be a geometric sequence, it could just be a sequence. A sequence is any kind of pattern that follows, or a list of numbers that follows a pattern. And so a series is going to be a sum of that sequence. Okay, so what we're going to talk about today is something called summation notation. Summation notation, and it is represented by the Greek capital letter S, and this stands for sigma. And it is Greek, a capital letter S, and it means sum. So as soon as you see this symbol, it means sum. Okay, and so there is this funky notation. And at the bottom, sometimes we use N and sometimes we use K. And so the bottom, this is called the index. And it is the starting term number, not the value, the number. And generally it's going to be 1. You start with the first number in the list. And the top number, that's not a hashtag, the top number is going to be the ending term number. And then you're going to have this equation right here. Okay, so this is what it looks like, and have your calculator handy. If I ask you to find the sum sigma, this fancy looking S. Some of my S's look better than others. And I'm going to use K, and it doesn't matter. K goes from 1 to 4 of K squared plus K. Okay, so notice how I said that. K goes from 1 to 4 of K squared plus K. And so what this means is, starting with the first term, plug in 1, and that's going to be 1 squared plus 1, which is 2. The second term, I'm going to plug in 2, and that's going to be 6. I hope no one's here to correct me. No one's here to correct my careless mistakes. Just me and the dog, and last I checked, I don't think he was very good at Algebra 2. How about 12? And the fourth term, and that's going to be 20. Okay, and so sigma means take all these terms, add them together, and I believe that is 40. So the answer to this question, you're not solving, you are not solving, you are evaluating. So you're going to plug in the bottom number to the top number and figure it all out. And that is sigma, a sum. They do get a little bit more complicated. So let's look at sigma, and I'm going to use N this time. And this time I'm going to give you -1 to the N times n squared. Okay, so starting with 1, find the first term, the second term, etc. And then we're going to add them all together. And let's see what kind of happens with this pattern. So when you plug in 1, that's going to be negative 1 to the first times 1 squared, which I believe is negative 1. And when you plug in 2, that's going to be negative 1 squared times 2 squared, which is positive 4. Notice that this sequence, the series, which is the sum of the sequence, this is neither arithmetic nor geometric, but the pattern still exists. And I believe that's negative 9. And you plug in 4, and that's going to be 16. And then you plug in 5, blah, blah. And that's going to be negative 25. Okay, and then we're going to add those all together. So I'm going to get negative 1 plus 4 minus 9 plus 16 minus 25. Negative 15. Okay, this is special. You'll notice that the terms alternate between being positive and negative. So the first term was negative, the second term was positive, the third term was negative, the fourth term was positive, the fifth term was negative, etc. And that is referred to as alternating terms. And it's going to be super important that you understand how to create an equation with alternating terms. So alternating terms means one term is positive, the next term is negative, one term is positive, or the other way around. And to create alternating terms, either negative 1 to the n, k, who cares, or negative 1 to the n plus 1. If n is odd, this means that the first term is negative. And then the second one here, negative 1 to the n plus 1, that means your first term is positive. Okay, so that's how you're going to create alternating terms. Okay, so here's what we're going to do. I'm going to give you the sequence list of numbers, and you're going to write using summation notation. I'm not asking you to find the sum, I'm asking you to write. Sigma notation, summation notation, same thing. I highly recommend you pause the video, try and figure it out on your own, and then come back and check. Okay. This is an arithmetic sequence. D is 4. My first term is 7. So the equation T sub n is going to be T sub 1 plus 4 times n minus 1, which is 4n plus 3. That's my equation. My first term, T sub 1 is 7. Okay, so if I start with the first term, the index is not 7. The index is 1. I'm starting with term 1. Okay, well, where am I ending? Well, this ... tells you where you're ending. ... that's infinite. So my ending term number doesn't really end, it's infinite. And then the equation is 4n plus 3. And that is how you write using sigma notation. Okay, I'm going to give you one more of these. Again, I encourage you to pause the video and see if you can figure it out. I'm going to give you another sequence. Negative 1 plus 2 minus 4 plus 8 ... minus 16,384. And I want you to write it using sigma notation. Pause, see if you can figure it out. So the first thing you should have done was, what kind of sequence is it? Is it arithmetic, geometric, or neither? And in this case, This is a geometric sequence, and r is -2. But notice that I'm alternating terms. My first term is negative, my second term is positive, etc. Okay, well, the problem here is, great. I'm going to start with n or k is 1. I don't know, though, up here, what's that going to be? And I know that my equation, t sub 1 times r to the n minus 1. Okay, well, I got to figure this out. Logs. So I did a little bit review of logs on Wednesday. I know that the nth term is negative 16,384. So I'm in the list, -1, 2, -4, 8, -16, +32, -64, 128, blah, 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 blah. Somewhere down the line, I'm going to hit -16,384. Is that the 12th term? Is it the 13th term? Is it the 14th term? I don't know. And that's what we have to figure out. And I'm going to need to use logs because I doubt that off the top of your head, you know 2 to what power is 16,384. Okay, so -16,384 is going to be equal to t sub 1 times n 2, and sorry, in this case, -2 to the n minus 1. Divide both sides by -1. Okay, just like Wednesday, I'm going to temporarily ignore the negative, temporarily, and I'm going to use logs. The log base 2 of 16,384 is equal to n minus 1. Okay, you cannot use a graphing calculator on the final exam. So I recommend practicing using the scientific calculator. Log base b of a, change of base. The log of the argument over the log of the base. That's change of base. So on the calculator, you would do the log of 16,384 divided by the log of 2. And I think that is, of course, I didn't do it ahead of time. So I think that is, let's see here, the log base 2 of 16,384, 14. So n is going to be equal to 15. Okay, so 16,384 is the 15th term in the list. So that is going to be the number on top of my sigma. Well, wait a second, Ms. Babiak. You said that we were going to temporarily ignore that negative. Okay, so here's what we're going to do. Let's check. When you plug in 15, do you get negative 16,384. So if t is 15, is t sub n negative 16,384? And if it's not, then I'm going to have to alternate that k minus 1, k plus 1. Here's what I mean. Okay, so -1 times -2 to the 15 minus 1, does that equal 16,384? -2 to the 14th is 16,384 times -1 is indeed negative 16,384. That is your intro to series. Okay, so now I'm going to move on to specifically arithmetic series. Okay, so arithmetic is addition and subtraction, a sequence created by addition and subtraction. So there are going to be special formulas that you're going to need to know for your quiz, which is next week on Wednesday. Okay. Grab a calculator, and I want you to add, like, just do it the long way, 5 plus 11 plus 17 plus 23 plus 29 plus 35 plus 41 plus 47. Pause the video, take a minute, see what you get. And I think when you add them all together, it is 208. Yeah. Well, surely there's got to be a shortcut. We know it's arithmetic. D is 4. How about D is 6, not 4? This is what happens when I'm by myself and, the dog can't speak and correct me. Notice that when you add the first and last terms, you get 52.